all of a sudden we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy like the Milky Way galaxy with 100 billion stars.
For centuries, our current understanding of the universe said that its beginning was a long, slow process. After a period of complete cosmic darkness, stars and galaxies would gradually come into being. But the James Webb Space Telescope has now peered beyond that darkness, and its discoveries have sparked a serious debate among astronomers. It started with these strange, compact objects, which some researchers informally nicknamed little red dots. They appear to be too massive and too numerous for their early age. But they are just the beginning. Webb's latest findings point to a trio of cosmic mysteries, including galaxies that appear surprisingly mature and black holes that seem impossibly large, that challenge our current understanding of cosmology. So what are these strange objects, and could they rewrite the history of everything? Before we look at these discoveries, we need to understand where and when the James Webb Space Telescope is looking. Our standard cosmological models say that in the moments after the Big Bang, the entire universe was a hot, dense, foggy plasma. It took nearly 400,000 years for this to cool enough for protons and electrons to combine into neutral hydrogen atoms. This kicked off a period known as the Cosmic Dark Ages. There were no stars, no galaxies, and no sources of light. The universe was filled with a dense fog of hydrogen gas that absorbed light. This era lasted for hundreds of millions of years. The prevailing theory was that the first stars eventually ignited, and their intense radiation began to ionize the surrounding hydrogen like tiny flashlights, slowly clearing the fog. This epoch of reionization gradually made the universe transparent. For decades, scientists believed this was a slow process, dominated by small, faint galaxies. The primary mission of the Webb telescope was to capture the faint, red-shifted light from these first galaxies. It was designed to see the universe's baby pictures. But when the first images came back, astronomers found what looked like fully grown adults in a time when only infants should exist. And that has changed everything. The first clue that our cosmic origin story might be incomplete came in the form of tiny, intensely red objects scattered across Webb's deep field images. Informally nicknamed little red dots by some astronomers, these objects were completely undetected before JWST and appeared in large numbers around 600 million years after the Big Bang. Initially, nobody could explain them. If they were galaxies, their red color suggested they were either full of old stars or shrouded in dust, but neither explanation fit the timeline. Some even dubbed them universe breakers, because they challenged models of galaxy formation. As Webb's spectrographs analyzed the light from these dots, a new theory began to take shape. For many of them, the light showed signs of gas swirling around a central object at incredible speeds. This pointed to the majority of these little red dots being active galactic nuclei, or baby quasars. In other words, rapidly feeding supermassive black holes. This discovery solved one problem, but created another. If these are infant supermassive black holes, how did they get so big, so fast? A leading idea is that these aren't traditional galaxies, but a completely new class of object. One theory suggests a little red dot could be one gigantic cloud of gas powered not by nuclear fusion, but by a black hole at its core. In this scenario, we might be seeing the very first stage of a supermassive black hole's life. The little red dots were just the beginning. As astronomers looked deeper, they found monsters. Webb has identified supermassive black holes with masses up to a few million times that of our Sun, existing when the universe was less than 800 million years old. One fascinating example is at the center of the galaxy GNZ11. Webb found clear evidence that a black hole there existed just 400 million years after the Big Bang, making it the most distant active supermassive black hole ever recorded. This presents a profound problem. According to our standard model, black holes form from collapsed stars and need to feed over billions of years to become supermassive. Finding one so massive, so early is like finding a redwood tree that has reached its full height in a few weeks. It simply shouldn't be possible. So how did they do it? What's the secret to their impossible growth? One way we might think is the direct collapse model. This idea posits that, under certain conditions, massive clouds of pristine gas in the early universe could have collapsed directly into a large seed black hole, bypassing the need for a star to form and die. These heavy seeds would have had a massive head start.
Well, there is another hypothesis which has recently become popular among some scientists, known as conformal cyclic cosmology. Nobel laureate Dr. Roger Penrose says that there may have been a universe before ours. He postulates that black holes from a previous universe could have survived the Big Bang and acted as seeds, jump-starting the formation of galaxies and supermassive black holes in our own eon. While this idea is highly speculative, it shows how difficult it is to explain Webb's discoveries with our current physics. As if impossibly large black holes weren't enough, Webb's third mystery concerns the galaxies they live in. The telescope has discovered a population of galaxies that appear surprisingly massive, existing when the universe was only 500 to 700 million years old. When the discovery was first announced, one researcher described running his analysis software and seeing a galaxy with the mass of 100 billion suns at an impossibly early time and nearly spitting out his coffee. According to standard cosmology, there simply wasn't enough time or matter for such galactic heavyweights to form so quickly. These galaxies aren't just massive, they also appear surprisingly mature. Webb's instruments have detected the chemical signatures of heavier elements like carbon and oxygen. Finding them in such early galaxies means generations of stars must have already lived and died, a process that should take much longer. One record breaker, a galaxy designated MOM Z14, existed just 280 million years after the Big Bang. The detection of elements like carbon and nitrogen in its spectrum is still tentative, but it pushes the timeline for galaxy formation right to the edge of the Big Bang itself. One groundbreaking hypothesis suggests we might not be looking at normal stars. Some of these incredibly bright, early galaxies could be home to dark stars, colossal spheres of hydrogen and helium powered not by fusion, but by the annihilation of dark matter particles at their cores. While the existence of dark stars is a theoretical possibility, JWST has identified candidates that match the expected signatures. However, there is no confirmed detection of dark stars as of October 2025. Well, everything the Webb telescope has discovered so far poses a challenge to our understanding of the universe. It's no surprise that in its first few years, the JWST team has broken a slew of cosmic records. Finally, if you have finished this video, don't forget to comment on what you think about these discoveries and what you think about the age of our universe. From little red dots that could be a new class of object to impossible black holes in galaxies that defy our models, the James Webb Space Telescope has revealed a completely new chapter in our origin story. It seems the early universe was not slow and methodical. It was a place of breathtaking speed and creativity, capable of building massive structures in a cosmic blink of an eye. These findings don't necessarily mean our core model of cosmology is broken, but they do show that it's incomplete. There are fundamental pieces of the puzzle we are clearly missing. Thanks to Webb, we're looking back through time to the very edge of the beginning. And as its golden eye continues to stare into the abyss, one thing is certain. The universe is far stranger and more magnificent than we ever dared to imagine. The greatest discoveries are yet to come.